Hi everyone, my name is Apoorv and I'll be doing the assigned Endsem questions for Mat 104 exam, and I have put the question in the description box below. Okay, so in the sixth question, the given equation is y double dash plus 16y is equal to 4 direct delta function of t minus 3 pi, where the initial conditions given are y at 0 is equal to 0 and y dash at 0 is also equal to 0. Now here the direct delta function signifies the instantaneous change of the position of the block in the given mass spring system. A real life phenomena is captured by the direct delta function can also be like can also be an impulse. Okay, now I'll talk about the direct delta function. So direct delta function has two values, infinity and 0. It is infinity at t is equals to a, and for rest all the values that is t where t is not equals to a, it is 0. Okay, there are some identities of the direct delta function are given by integration of direct delta of t minus a from 0 to infinity is given by a, and integration of direct delta function of t minus a into f of t from 0 to infinity is given by f of a. Now I'll be drawing the graph of the direct delta function, graph of the direct delta function, where this is a. Now this, since at all the points it is the direct delta function is tending to 0 and at a it is tending to infinity, so according to me this will be the graph of the direct delta function. This is just a rough graph of the direct delta function. Now I'll take the Laplace transform of direct delta function, which is equal to integration of e to the power minus st into direct delta function of t to the power minus st into dt from 0 to infinity. Now comparing this and this equation, we conclude that e to the power minus st will be equal to ft. So therefore, concluding that Laplace transform of direct delta of t minus a can also be written as fa, that is e to the power minus sa. Okay, now the homogeneous solution of the above equation can be written as y double dash equation. This is the homogeneous equation, the above okay, equals to 0. This is because this is the homogeneous solution since we take RHS equals to 0, that is GT is equals to 0 for homogeneous solution. So its general solution for homogeneous equation also is C1 cos omega t plus C2 sin omega t. This will not be used in the solution. I just wrote it down to help me plot the graph, to help me for the intuition of the graph of the solution of the equation y double dash plus 16y is equals to 4 direct delta of t minus 3 pi of the given equation. So according to me, to my intuition, the graph can be drawn something like this. The graph will be something like this. Now by this we assume that it will have a sinusoidal graph, and also because it is the graph of a mass swing system. Okay, here. Okay, now solving the above
Solving the above equation, we'll solve it by taking Laplace transform of both the sides, that is Laplace of y dash plus Laplace of 16y equals to Laplace of 4 into direct delta function of t minus 3 pi. Now Laplace transform of y double dash plus Laplace 16 into Laplace transform of y is equals to 4 into Laplace transform of direct delta function of t minus 3 pi. Now we can see that we already found out the Laplace function of direct delta function here, which is equal to e to the power minus sa. Here a can be replaced with minus 3 pi, so the value of the RHS will be 4 e to the power minus s into a, that is 3 pi. For LHS, first by the identity we know that Laplace transformation of y double dash is equals to s square into Laplace transform of y minus s into y at 0 minus y dash at 0. Now by the initial conditions it is given that y at 0 and y dash at 0 both are equal to 0, therefore these two will become 0. So Laplace transform of y double dash can be given as s square into Laplace transform of y. Now putting the value here, we get that s square into Laplace transform of y plus 16 into Laplace transform of y is equals to 4 into e to the power minus 3 pi s. Now taking Laplace transform of y common, we get that, and s square plus 16 on the other side we get 4 by 16 plus s square into a to the power minus 3 pi s. So y can be written as Laplace inverse of e to the power minus 3 pi s into 4 by s square plus 16. Now we know Laplace transform of sin at is given by s square plus a square. Now comparing these two, we can compare, by comparing these two, we can use it. So y is equals to Laplace inverse of e to the power minus 3 pi s into Laplace transform of sin 4t. Okay, now there is an identity that gives Laplace inverse of e to the power minus sa into Laplace transform of function f of t is given by function f of t minus a to unit step function t minus a. Okay, so therefore comparing this and this, we get that the final solution of y is equal to sine 4 into t minus 3 pi unit step function t minus 3 pi. Now I used a 3D graph plotter software, and this was the graph that was plotted of the given solution. 3 pi is equal to
You can see that this graph is similar to the graph that I plotted using my intuition.